This is the first worksheet we will be covering and completing for chapter 7. This worksheet is called the roll mole worksheet. It is designed to be used by answering the problems 1, 2, 1 prime and 2 prime first, and then we will fill in the blanks on the equalities. Okay? So let's start. At the top you have the given information. We know that there are 40 nickels in a roll and 40 quarters in a roll, and it's known that a nickel is worth 5 cents and a quarter is worth 20 cents. For that reason, if we look at this, then what will be the value of a roll of nickel? The value of a roll of nickel will be $2, since there's 40 nickel and each nickel is worth 5 cents. And then what's the value of a roll of quarter? It will therefore be $10. Now let's take a look at question 1 prime and 2 prime. In order to answer question 1 prime and 2 prime, we will need to know, okay, the value, and the value is the same as the mass in the question 1 prime and 2 prime. So where do we find the mass of a mole? The mass of a mole can be found on the periodic table. So if you take a look at your periodic table right now, you will see that in your periodic table, in the box that contains the sulfur element S, you have a number underneath, and this number is called the atomic weight. Therefore, the mass of a mobile sulfur will be, per periodic table, 32.07 gram, and the mass of a mole of bromine, and if you look at your periodic table in the box that contains the Br symbol, you will see underneath 79.90 gram. Okay? So again, the information for 1 prime and 2 prime can be found on the periodic table. But the question is, what is a mole? Okay? Because I just told you that this is the mass of a mole, and this mass vary depending on what the mole contain. The mole is actually equal to 6.02 times 10 to the 23rd, and is a counting number, like a dozen, which is 12, a gross, that is 144, or a ream, that is 500, and so forth. Okay? We use the mole to count. We usually use this counting number, like the dozen, the gross, the ream, to count objects such as eggs, pencil, or sheets of paper. Okay? The problem is atoms are very, very small. Therefore, the measurement that we're going to use in a lab measuring equipment can only be made on very large number. And these numbers are on the order of the Avogadro's number, which is Avogadro's number 0.2 times 10 to the 23rd. Okay? The mole concept is one of the most difficult concepts in chemistry, and for that reason, I'm trying to show you the analogy between something that you might be more familiar with, which are money and roll of money, and it's very similar. So just like take your time and try to understand what we're going through right now. Now, using the information of problem 1, 2, 1 prime and 2 prime, what we'll do is we actually is going to complete the table that is underneath. And at this point, okay, I want you to forget that a nickel is worth 5 cents and a quarter is worth 25 cents. You must not use that information when you're going to be solving problem 3 to 6, or all the purpose of this worksheet is defeated. Okay? The reason why is because nobody will ever remember the mass of an atom or of an element or a formula unit for a compound. For that reason, this worksheet points out the information that you are allowed to use to solve the problem. Okay? To use this worksheet most effectively, we're going to work problem 3 and 3 prime side by side. Okay? And I'm going to show you that the reasoning is identical. You need to be aware, okay, of the reasoning for each question, being the 3, 3 prime, or 4, 4 prime, and see how there's a pattern, okay? That moles are not really impossible to work with. Avogadro's number is just too large to picture, okay? And usually you do not set up money problem, but you will see how similar it is between money and mole, and I hope this will help. So based on the information that we have at the top, we're going to complete the box here, okay? We know per given data that a roll contains 40, and it's a measurement, okay? It's a counting number as a dozen, as a gross, as a ream, as a mole. Therefore, in a roll of nickel or in a roll of quarter, we will find 40, okay? We have calculated the value in question 1 and 2, therefore we know that a roll of nickel is equal to $2 and a roll of quarter will be equal to $10. We're going to use question 1 prime and 2 prime to fill in the blank for the two other lines. We just talked about the mole, okay? And I told you that the mole is a counting number. It's called the Avogadro's number, and therefore, as I said, value. The mole, no matter what you're talking about, will be equal to 6.02 times 10 to the 23rd. And it's a very big number. Okay. So, now, using the information we have in 1 prime and 2 prime that we found on the periodic table, we know that a mole of sulfur weighs 32.07 grams and a mole of bromine 79.90. What we're going to do now, we will solely use the information contained in this box to use dimensional analysis to solve, okay, the questions 3 to 6 and 3 prime to 6 prime, okay? And we have to show our setup. You have to understand what are the similarity between the two, okay? In this analogy again, the value in dollar is like the mass in gram. The number of coins in a roll is like the number of atom in a mole. Rolls of coin are like moles of atom. First question. So let's take a look at this one. How many nickels are in 3 rolls of nickel? Notice that we talk about nickel because if I've asked you how many coins are in a roll, you will be like, well, I know there's 40 coins in a roll, okay? So we have 3 rolls of nickel. We want to use the dimensional analysis to cancel the rolls of nickel and to convert into nickels. We know that there's 40 nickel per roll. Therefore, 3 roll will contain, we're going to cancel the roll of nickel. We're left with nickel, which is what we wanted. And 3 roll of nickel contains 120 nickels. We can do very similarly problem 3 prime. So what's the question in 3 prime? How many atoms are in 3 mole of sulfur? Where the given is 3.00 mole of S. We want to cancel the mole of S and convert into atoms of S. Per definition, Avogadro's number, which is the counting unit, 1 mole consists of 6.02 times 10 to the 23rd. Take a look. My mole cancel, and I'm left with atom of sulfur. Therefore, 3 mole of sulfur contains 1.81 times 10 to the 24 atoms of sulfur. Notice your sig figs here. 3 sig figs, 3 sig figs. My answer is given to 3 sig figs. Let's keep going and do problem 4 now. We want to know now the value in dollar of 3 rolls of nickel. Again, remember that you have to forget that a nickel is worth 5 cents. Okay, we want you to forget that information. The reason why is because you don't know by heart the mass in gram of any element from the periodic table. You have to consult the periodic table. Okay, so what do we have here? We know that we're starting with the given data, the 3 roles of nickel. We want to cancel the roles of nickel and convert into the value in dollar. If we look at the table above, we know, okay, per this equality right there, that a roll of nickel is $2. A roll of nickel is $2. Therefore, 3 rolls. Again, we're going to cancel the roll. We're left with the dollar value is equal to $6. Let's do very similarly problem for prime. What is the mass of 3 mole of sulfur? We want to know the mass. Okay, that's what we're looking for, the desired unit, the mass unit gram, and we're given moles. So we're going to start with our 3.00 mole of S. This time we want to cancel the mole of S and convert to gram of S. Well, this relationship here, this relationship here allows you to fill in this blank. Per periodic table, we know that every mole of S contains 32.07 gram of S. Therefore, 3 mole of sulfur has a mass of 96.2 gram of sulfur. Notice again, okay, that we have 3 sig figs here, 4 sig figs here. The answer is given to the least amount of sig fig, 3 sig figs. We keep going now with the next problem. So we want to know how many rolls of quarter is $500. So the given value is dollar, and we want to know the number of rolls. So what we will do is start with the $500. Now we want to cancel the dollar and convert to rolls of quarter. Okay, I'm just going to use the symbol Q for a quarter. Therefore, do we know the value of a roll of quarter? I'm going to go back up here, and you see that a roll of quarter is equal to $10, because we have to forget, okay, that a quarter is actually 25 cents. Therefore, 1 roll is equal to $10, and we get that we need 50 rolls of quarter in order to get $500. Notice that again, the unit cancel here and we're left with rolls of quarter, and before our units were to cancel here and we were left with gram of sulfur. 5 prime now. So let's take a look at this problem. How many moles? So we're looking for the number of mole now. Mole of what? Bromine. Knowing are in 53.8 gram of bromine. So we're going to start with the 53.8 gram of Br. We want to cancel the gram of Br and convert into mole of Br. Notice that again, my gram of Br cancel and I'm left with my mole. We're going to use the analogy at the top. Okay, I mean the relationship, at the top from the periodic table, that 1 mole of Br is 79.90 gram. 1 mole of Br weighs 79.90 gram. Plug this into your calculator, and to 3 sig figs, you get 0.673 mole of Br. Again, sig figs wise, notice that I have 3 sig figs here, 4 here. The least amount of sig fig is given for my answer with 3 sig figs. So, let's take a look at 6 and 6 prime now. Okay, again, it's going to have. We want to know how many nickels are in $500 of nickel. So we start here with $500. Okay, and we want to cancel the dollar amount and convert into nickels equal. So, do we know the relationship between the dollar and the nickels? We're going to go back up here. Dollar, nickels, okay. Going through, what we have here is called the bridge unit. So what we're going to do is you always use your bridge unit to separate them. So we're going to move this one on the side. Coming back, we have the bridge unit, that is the roll of nickel. The roll of nickel, I'm going to use N for the symbol of nickel. And now notice that your dollar amount cancel and your roll of nickel cancel, and then you left for nickel, and you used the roll of nickel as the bridge unit, okay? The mole, the roll is your golden unit, your go-to unit, and now we're going to fill in our blank. One roll is worth $2, and in one roll there's 40 nickel. Therefore, we'll have 10,000 nickels. We can do something very similar on the right here. How many atoms are in 1.50 grams of bromine? Well, I have 1.50 grams of bromine. Okay, I want to cancel my gram of bromine and convert to atoms of bromine. If I look up here, I have my grams of bromine here, my atoms of bromine here, and here is my bridge unit, my golden unit, the mole. Therefore, I'm just going to move my atoms, create another conversion factor where the mole appears, because the mole cancel to one another. So let's see. My gram cancel, my mole cancel, and I'm left with atom. And I can use my relationship where in a mole there's 79.90 grams of bromine, and in a mole of bromine there's 6.02 times 10 to the 23rd atoms. Therefore, 1.50 grams of bromine consists of, let me type this again on my calculator. I think I have a sig fig problem. 1.50 to 3 sig figs, 1.13 times 10 to the 22 atoms of Br. The answer has to be given to 3 sig figs, because I have 3 sig figs here. 4, 3, it's only multiplication and division, least amount of sig fig. My answer is to 3 sig figs. For problem 3, 4, 5, 6, I actually didn't use sig figs because all these numbers are exact number, okay? We're literally are dealing with value in dollar and coins and roll, so we only have exact number. On the other hand, Avogadro number is measured, so I have sig figs involved. Moles are measured, sig figs involved, and masses, molar masses are measured as well, so sig figs are involved. That's why I had to use sig figs for 3 prime, 4 prime, 5 prime, and sig prime. So this is the end for that worksheet, and please come to the discussion session if you have any questions. Thank you.